Hey folks, welcome to Chapter 2, Lesson 10, Perpendiculars and Distance. Draw the shortest possible line segment from point P to line L, and what's the relationship between the line segment you just drew and line L? All right, go ahead and try it. You probably wound up drawing something like this, right? It's like the shortest distance from P to L. Notice, it's forming a right angle here. These are perpendicular lines. Perpendicular lines are the key to the shortest distance from P to L. All right, here's the problem we're going to be tackling. Line L contains points at -5, 3, and 4, -6. Here, I'll graph those two. Find the shortest distance between line L, which is the line between them, and point P. So we have to do this in 4 steps. Okay, 4 steps. First step is you have to find the equation of line L. Find the equation of line L. How do you do that? Well, 3 parts to this first step. Part 1, use the slope formula, y2 minus y1 over x2 minus x1. Find the slope of the line. You just use the ordered pairs -5, 3, and 4, -6, plugging them in for x1, y1, and x2, y2, and you get a slope of -1. You can check to see if you're right by looking at the graph. Does it look like the graph has a slope of -1? Sure it does, right? Look over here. If I go down 1, I go over 1, down 1, over 1. Okay, that's clear slope of -1. Next thing you want to do is you want to get the point slope form of the linear equation. It's called the point slope form because x1, y1 is any point on the line, and m is the slope of the line. So we just fill in the information. I used the ordered pair -5, 3, and I used this slope right here. Done. Last part of step 1 is to convert point slope to slope intercept. You do that by distributing on the right and then moving -3 to the other side. So go ahead and distribute the negative sign, then go ahead and distribute -1, then bring 3 to the other side, you get y equals -x minus 2. We can double check to see that this makes sense with a line. It's got a slope of -1, we already confirmed that. It's got a y-intercept of -2, that seems perfect. All right, step 1 done. We have got the equation of line L. Next, we want to get the equation of the line W, which is the line through P of perpendicular to L. I drew it in here for you can visualize it better. It's the line through P perpendicular to L. We need that equation of that line. So how do you do that? Well, we'll get the equation of line W first by finding the slope, but you can't use the slope formula. You can't use y2 minus y1 over x2 minus x1. That would be cheating. That would require you to know 2 ordered pairs on the line W, but you don't. You really only know this ordered pair. Now you're probably saying to yourself, yeah, I know this ordered pair right here. Right? It's -2, 0, or this one right here, which is 2, 0. I know all these. No, you don't. Just I gave you the line. I drew it in for you. Okay, you can't do that. That's not how we approach this algebraically. You have 1 ordered pair. So the way that you're going to get the slope of the line W is using this relationship. The relationship between line W and line L, that they're perpendicular lines, therefore their slopes are negative reciprocal slopes or opposite reciprocal slope. Okay, so if the slope of line L was -1, the slope of line W is going to be the negative reciprocal of that, which is 1. Okay, don't forget that step. Next part of step 2 is you get the point slope form of the linear equation. Again, you just use an ordered pair and a slope, fill in the information. Then you go to point slope by distributing the 1 and then bringing the 4 to the other side. Okay, what was step 1? Equation of line L. What was step 2? The equation of line W. Step 3 is we want to find the intersection of line W and line L, which is going to be this point Q. Now you say to yourself right now, I know it's -2, 0, done. No. Now, once again, you don't actually have this line drawn. I just drew it in there for you. You wouldn't know where Q is. Okay, so what you have to do is solve a system of equations. We have the equation of line L, which is right here. We have the equation of line W, which is right here. To find the intersection of the 2 lines, you just solve the system of equations. All right, so we're going to use elimination. I would suggest adding line 1 to line 2. If you do that, you get y plus y is 2y, negative x plus x is 0, and negative 2 plus 2 is 0. Divide both sides by 2, and you get y equals 0. Have we got the ordered pair Q? No. Clearly, the ordered pair Q is negative 2, 0. It's an ordered pair. We only have half of it. So how are we going to get the other half? You plug y back into the system of equations. I'll do this in the second equation. 0 equals x plus 2. Therefore, x is equal to negative 2, and I get the ordered pair negative 2, 0. Now, my picture allows you to check to see if you got the right Q, and we did. All right. What were the 3 steps so far? Step 1, get the equation of line L. Step 2, get the equation of line W. Step 3, get the point Q, which is the intersection of L and W by solving a system of equations. Last step. Now that we know the point P, which was given, and we know the point Q, which we just got in step 3, we can find this length right here, can't we? The distance from P to Q, just using the distance formula. So find the distance PQ by using the distance formula. There's the distance formula. Change in x, change in y, squared, added together. It's just the Pythagorean theorem rearranged. All right, what order pairs are we going to plug in? Like I said, P and Q. And then when you do that, you should get square roots of 32, which is the distance from P to Q. All right, let us say one more time what it is that we did in this problem. We did 4 major steps. Step number 1, we got the equation of line L. Step number 2, we got the equation of line W. Step number 3, we got the intersection of L and W, which is the point Q, by solving a system of equations. Lastly, we get this distance right here from P to Q using the distance formula. And now we have the shortest distance from P to L. All right, here's your homework assignment for standard and honors. Hope it goes well.